Hello everyone, this is Dr. Savitha M. In continuation with our discussion on corrosion science and metal finishing, in this video we shall be discussing on metal finishing. Right now, what is metal finishing? Right, metal finishing means it is the final phenomenon or the surface phenomenon involving the deposition of a thin layer of a noble metal on a polymer or a base metal, or conversion of the outermost layer, thin layer of the surface into its product, that is chromates or phosphates or oxide of the same metal. Okay? So this is called metal finishing. Now, why metal finishing is important? Metal finishing is mainly important for many of the reasons. Some of them are corrosion resistance, because in you are covering the base metal with a noble metal, it will obviously reduce corrosion. Then abrasion resistance, heat resistance, electrical resistance, chemical resistance, reflectivity and appearance, solderability, ability to bond to rubber, hardness, manufacture of electronic components. For all these, metal finishing is important, right? Next, let us simply understand first what is electroplating. Let us take the example. You suppose you want to plate something with the silver. Now what you will do, you will be taking a beaker. What you have to do is, what has to be plated, that is taken as anode, and on which what you have to plate, that is the article, has to be connected to the cathode terminal. Let us assume we are taking a spoon, and it has to be plated with the silver. So you will be connecting the spoon to the cathode terminal, and by what you have to plate? Silver. Silver is taken as the anode, and it is taken in a electrolyte solution. Connections are done. Then when the circuit is complete, what happens? Silver dissolves to give silver ions. Electrons enter the external circuit and then come to the cathode region, that is the article on the article. Silver from the solution goes near, it is now as present as silver ions, goes to near to the cathode, and then it accepts electron, that is reduction takes place, and silver get deposited. Okay, after some time the entire surface of the cathode gets deposited. That is how electroplating of silver is done. Okay, let us now take the example of gold plating. Let us assume that we need to coat this coin by gold plating. Right, here also same thing, the gold, whatever article which we have to um, coat, we are taking as cathode terminal, and then you are taking gold as anode. The it undergoes oxidation. Now gold liberates electrons, and then ions are also produced, gold ions. Gold ions go near the cathode surface, that is electrode surface, article surface. It accepts the electron and get deposited as gold. Okay, now to understand the principles of metal finishing, that means if you want to do electroplating process, then we need to understand these three principles, fundamental principle. One is polarization, decomposition potential, and over voltage. Right, now first let us discuss on polarization. Right, polarization means it is the creation of poles. Due to the creation of poles, the actual potential of the electrode varies. Right, we always tell the potential in terms of reduction potential. We tell that the metal has certain reduction potential. So by knowing the reduction potential itself, we will come to know what is the potential of that metal, that is the ability of that metal. But sometimes due to polarization, the electrode potential varies. We will understand better in the next slides. Now due to the polarization, there will be variation in the electrode potential. Right, why polarization takes place? There are two reasons. One is due to the inadequate supply or insufficient supply of electroactive species from the bulk to the electrolyte or the electrode. Okay, that means electroactive species means, suppose we are taking silver plating, silver ions, Ag plus ions will be the electroactive species. So from the bulk on the electrode surface, the as I mean inadequate supply. There is insufficient supply. Okay, or there's another reason, that is due to one of the steps involved in the deposition reaction of the ion is slow. These two are the reasons. Okay, accordingly, the first one is called as concentration polarization. Second one is called as over voltage polarization. Okay, let us understand this. Let us assume this is the anode and this is the article cathode. Okay, we need to deposit this anode, which undergoes oxidation, gives out the electrons from the external circuit comes to the cathode, metal ions are released to the electrolyte. From the electrolyte it has to go near the cathode surface. See, electron has come from the external circuit. It is now on the cathode surface or article surface. The electrolyte has been dissolved, it diffuses through the electrolyte, comes near the cathode surface, accepts the electron, get deposited. Similarly, see, one more electron comes, the electroactive species also is here, it accepts the electron, it's deposited, right? So this is the process of electroplating process. Okay, now let us assume this electroactive species is not coming near the cathode surface or the electrode surface. See, electron has already come. That means oxidation has already taken place. Electrons has come through the external circuit, but the metal ions which is present in the electrolyte now, from the electrode it is now in the electrolyte ion, right? It is present as electrolyte. Okay, this ions is not coming near. What happens then? The electron is waiting for the metal ions, but metal ions actually it is present in the bulk of the solution, but it is not reaching the electrode surface. Then what will happen, right? A question mark is there. What happens to this reaction? Now what happens to the reaction? Now in the cathode electrons are already present. Now electrons will now the cathode already has excess electrons. It will tell, it will be asking the metal ions, or it will be waiting for the metal ions to come, right? So it is, see, it is asking, it is requesting for the metal ions to come, right? Therefore the cathode surface will request the anode not to give any more electrons, because already it has certain electrons which is unaccepted, right? Therefore the entire cathode surface will be waiting for electrons, and it will not be accepting further electrons from the external circuit, right? So here is a policeman which is actually telling the metal ions to go. Okay, but there's a block here. That means something is there which is not allowing the metal ions to go near the cathode. In that case, the overall activity of the anode also reduces, cathode also reduces. That means the reaction comes to an end. The reaction will stop, right? Therefore, there will be charge accumulation on the electrode. That is, on this there will be charge accumulation, and there will be a variation in the electrode potential. Variation in the electrode potential means, suppose we are taking a we are considering the reduction potential. We tell this metal has certain reduction potential, and by knowing the reduction potential we can understand at what pace, or to what extent it accepts electron and undergoes reduction. But in this case, see, it is, if you have chosen article which is made up, which is having very good reduction potential, high reduction potential, then also if there is not availability of metal ions, then also the reaction will stop even though electrode potential is high. Okay, that such type of variation in the electrode potential due to the unavailability of metal ions from the bulk on the electrode surface is called as concentration polarization. Polarization, see, poles are produced, electrons are, it becomes negatively charged, right? Therefore it is called concentration polarization. Okay, so this is one type. The other type is over voltage polarization. Now let us assume the electroactive species are present in the electrolyte. Okay, now the cathode surface is waiting for the electroactive species, because from the external circuit electron comes and it will request the metal ions to come. Now let us assume the metal ions which has to go near the cathode surface, it has to undergo a multi-step reaction. Let us assume this. Now in the first step, this reaction is taking place. In the second, this reaction is taking place, and the third step, it goes and accepts electron and getting deposited. Okay, therefore till then the electrode surface, that is cathode surface, will be waiting for waiting for the metal ions, because each step requires its own time duration. Therefore, if one of these step is slow, then overall time required by the electroactive species to reach the cathode surface will be more. Therefore, the potential of the cathode, okay, again article varies, because it will have to wait until one set of reaction takes place. It cannot accept the next set of electrons, right? Therefore, automatically the rate of the reaction slows down. This is called as over voltage, I mean polarization due to over voltage, right? If any one of the reduction reaction step becomes a slow, charge accumulation takes place on the electrode, and there is a variation in the electrode potential. Okay, whether there it is by concentration or by any of the step being slow, in both the cases the reaction stops. Okay, see, we can explain, we can understand by this Nernst equation, which tells we have derived this. The video is also uploaded. The derivation of Nernst equation, it tells that for a single electrode, it is the potential for a single electrode. It depends upon the metal ion concentration, right? Now the electrode potential during the electrolysis process. Now if Mn plus, that is metal ions, availability is less, it is not diffusing, it is not available for the reduction reaction, then the potential of the electrode is affected. Okay, next is suppose there is I mean generally the availability of metal ions is due to the less diffusion. Okay, now diffusion may be caused due to concentration gradient between the bulk and the vicinity of the electrode. Next is if the equilibrium is slow, then also the potential of the electrode changes, right? This is called concentration polarization. And the next one is the when there is multi-step reaction, several steps are involved for the reduction, and if any one of the step is slow, the overall reaction rate will be slow. Okay, so this also leads to polarization, and this type of polarization is called as over voltage polarization, right? Now whether it is concentration polarization or over voltage polarization, both will lead to change in the electrode potential, and thereby affect the what uh, plating process, right? To certain extent, concentration polarization can be eliminated by stirring the solution, because concentration polarization is mainly because of unavailability of the metal ions from the bulk. uh, so if you mix properly, the diffusion will be faster, the metal ions will go near the cathode, right? But if the polarization is due to over voltage, then by just mixing you cannot make the reaction fast, right? Therefore we need to understand, whenever we um, do the electroplating process, we need to overcome the polarization process. Okay, polarization, that means if at all there is concentration polarization, then we need to continuously stir the solution, right? If it is due to over voltage polarization, then one of the step which is slow, we need to supply extra energy so that reaction will be faster, and then the overall process will be fast. Okay, now what are the factors affecting the polarization? It depends upon the factors like nature of the electrode, its size, shape and composition, electrolyte concentration and its conductivity, products formed at the electrode, temperature of the electrolyte, and rate of stirring of the electrolyte. Next is the next term that we should understand is decomposition potential. Now, decomposition potential means that the word itself tells the potential required for the decomposition, continuous decomposition, right? Now, It is defined as the minimum external potential required for the continuous electrolysis of the electrode. Okay, now let us take the example of electrolysis of water. Right, in electrolysis of water, two platinum electrodes are taken. One is anode, another one is cathode, and it is dipped in the electrolyte, and electrolyte is generally acidified water. Okay, now what is our requirement? Electrolysis of water means um, hydrogen gas should be evolved, oxygen gas should be evolved. That should be our product. Okay, the primary reaction is water decomposing or dissociating into hydrogen and oxygen gas. Okay, now here is the setup again. See, setup is here. It is seen that the theoretical potential, theoretically if you calculate 1.23 volts of energy is required to start the reaction. That means if you supply 1.23 volts in the battery, continuously oxygen and hydrogen will be liberated. That is the theoretical consideration. But practically when you do this, when you set up this, when you practically set up, take electrodes, take electrolyte, and then connect it to the battery and supply 1.23 volts, continuously you will not get the product. Okay, continuously the reaction will not proceed. And it is seen that if you supply, instead of 1.23, if you supply 1.68 volt, then the continuous evolution of gases will be produced. Okay, now that means 1.68 is the experimental potential, whereas 1.23 the theoretical potential. Okay, now why this happens? This is because when suddenly, initially you supply 1.23 volts, some of the hydrogen and oxygen gas will be released. These actually should escape out, get collected, but it will sometime, it will get accumulated over the electrode. We have chosen two platinum electrodes. They are chosen because they are inert, because our actual reaction is electrolysis of water, where electrodes are just as conductors, right? Only for connections we are taking anode and the cathode. But suppose hydrogen gas and the oxygen gas get accumulated on the electrodes, then they will start as secondary. They will convert this inactive or inert electrode into active gaseous electrode. Okay, that means here there will be accumulation of oxygen, here there will be accumulation of hydrogen. Now these are active electrodes. Electrolyte anyway is there. It constitute, forms an secondary cell within the primary cell. Our primary cell is liberation of, breaking of water into hydrogen and oxygen. Now what happens is, due to the accumulation of the products, the secondary cell is produced, and then it produces a back EMF. Right, now this back EMF will be opposing the applied EMF. Right, therefore the primary cell, that is liberation of oxygen and hydrogen, will not take place until the applied EMF is greater than the back EMF. Okay, and it is found that if you supply 1.68 volt only, then only there will, all the back, the back EMF will be overcome, and you will continuously get hydrogen and oxygen liberation. Right, therefore this is the experimental voltage. Now how to find out the decomposition potential? This can be done only by trial and error. For example, you take electrodes, you take electrolyte, supply some voltage. Okay, and then see whether there is current is passed through. Okay, if it is continuously giving the deflection, then that is itself is the decomposition potential. But generally it will not give, it will suddenly stop. Okay, when it suddenly stops, you have to increase the potential. Again you have to see, like that, by varying the resistance and varying the applied voltage, the varying current is noted, and you have to plot a graph. Okay, by plotting a graph wherein current versus applied voltage, as you increase the applied voltage, current, you whatever value you are getting, you have to plot the graph. See, applied voltage increases, current little bit increases, but again it stops. Again, if you increase the applied voltage a little bit, current there will be flow, again it will stop. Okay, similarly you go on increasing, and one time you can see that at a certain current applied voltage there will be continuous flow of current. Okay, and if you plot a graph and draw two straight lines, the intersection will give you the decomposition potential. Therefore, uh, this is the minimum potential. See, there is continuous increase, right? So this is the minimum potential that is required for that cell to undergo electrolysis continuously. That is called the decomposition potential, right? Decomposition potential is very much required, and it is found, by trial and error method only. Once you find out the decomposition potential, when you go for a bulk method, the bulk deposition and all, you can directly fix this potential as the required potential. Okay, now knowledge of decomposition is potential is very much essential to carry out the electrolysis, since it is the minimum potential required for the continuous electrolysis. Otherwise, if you supply little bit less, the potential electrolysis reaction itself stops, right? Now another disadvantage, another significance is, suppose you have a mixture of ions, okay, and all the ions has to be deposited. Suppose you want an article to be deposited by copper, zinc and cadmium. Now how will you know which one deposits first, gets deposited first, whether the zinc deposits first or cadmium deposits first or copper deposits first? For this, we need to know the decomposition potential, nothing but the reduction potential, right? My previous video, we have already discussed on electrode potential, and we have understood that the electrode potential of copper uh, is higher than that of cadmium, which is again higher than that of zinc. Okay, therefore, first when you supply, when you pass current, copper gets deposited, and then when all the copper gets deposited, cadmium starts to get depositing, and after all cadmium starts gets deposited, zinc starts getting deposited. So you can find out the order of deposition if you know the decomposition potential. Okay, so it is very important in electro refining, electrometallurgy, extra, etc. Okay. Next is over voltage. Now, what is over voltage? Over voltage means the extra, the word itself tells over voltage, the extra potential that is required or that has to be supplied above the experimental potential or decomposition potential, to make the electroplating process a continuous process. Okay, in general, if you want the metals to get deposited, the experimental decomposition potential and theoretical decomposition potential is almost the same. But whereas if there is a gas involved, like hydrogen or oxygen or any gas that is involved, then this over voltage will be there. Generally, whenever there is a gas involved, the experimental decomposition potential will be higher than that of decomposition, theoretical decomposition potential, right? This extra, for example, if we had discussed on electrolysis of water, it is seen that by theoretically it is 1.23 volts, but actual potential takes place, actual reaction, evolution of gas takes place at 1.68 volt. Therefore, the extra voltage, that is 1.68 minus 1.23, will give you 0.45, which is the extra voltage given. Okay, that is called over voltage. Okay, what is the significance of over voltage, right? Now, whenever there is solution, generally aqueous solution has water, then during the electrolysis, when you pass electricity, hydrogen is also produced. Okay, H plus ions are also produced. Along with that, our metal ions also will be present in the electrolyte. Now hydrogen H plus ions also wants electron, metal ions Mn plus also wants electron, both requires electron, and the electrons are available at the cathode surface. Therefore, we need to know, whenever there is a competition, then which one gets deposited, right? So if you know the over voltage, you can control the deposition, or you can I mean control the deposition, deposition process. Okay, so due to the high over voltage of hydrogen, generally metal deposition takes place in preference to hydrogen. Therefore, we can be sure that the metal ions getting deposited over the what cathode surface or the electrode surface, right? Now, what are the factors affecting the nature, factors affecting the over voltage? That is nature and physical state of the electrodes, nature of the material deposited, current density, and temperature, right? This is what we have to discuss in electroplating process. In our next video, we will be discussing on some practical examples of electroplating process. Thank you.